Two foam boards can look nearly identical in a wall, but a thin facing can change how strongly that layer resists water vapor diffusion. Same foam, very different vapor behavior. Look closer at the two boards. The unfaced foam shows a cellular core. Vapor resistance depends on product and thickness. Now, the foil-faced version. The same foam core carries a thin metallic facing on one side. The facing may substantially increase vapor resistance. But the core still resists vapor to some degree on its own. The actual resistance depends on the exact product, thickness, facing, and tested data. There's a key distinction to see. Vapor diffusion is movement through materials. Watch the cyan particles pass gradually through an intact layer. Air leakage is different. It is movement through openings, joints, and transitions, and it can carry moisture with it. So remember this clearly. Vapor diffusion is not the same as air leakage. A vapor-resistant facing does not automatically stop airflow through an unsealed seam. Consider the seam question. Two foil-faced boards meet at a vertical joint. If the joint is left unconnected, red airflow can pass through. With a compatible seam treatment concept, the joint becomes part of a continuous air control path across the boards. Still, a board face is not a complete control plane. System performance depends on joints, edges, penetrations, and connections to adjacent layers. Now consider drying. A wall with wet exterior cladding after rain holds a small conceptual moisture zone behind the exterior layer. In one assembly, an outward vapor path lets moisture move gradually outward. Cyan arrows travel from the moisture zone toward the exterior. In another assembly, a foil-faced layer changes the resistance in one direction. The cyan arrows through that direction are reduced. When a facing changes vapor resistance, it can also change how the assembly dries. Vapor resistance can change drying paths. Whether the change matters depends on where the layer sits, what surrounds it, moisture sources, indoor conditions, climate, and the full wall design. Before comparing foam boards, start with 3 questions. First, what does the tested product data say? Core, facing, and thickness all matter. Second, what function is the layer intended to perform? Thermal, air, or vapor control? Each function has different requirements. Third, how does the layer connect to the full assembly? Seams, edges, openings, and transitions all shape the outcome. Here is the balanced view. Unfaced rigid foam vapor behavior depends on the specific product and thickness. Foil-faced rigid foam facing may substantially increase vapor resistance. Neither label alone defines complete wall performance. Foil facing can change vapor diffusion. It does not replace assembly design. Next note, vapor retarder paint. Educational information only, not project-specific design, installation advice, product selection, or code compliance guidance.